This is a video from section 4.3 in linear algebra. Prove that if the set of vectors u and v spans the vector space V, then the set of vectors u and u plus v also spans V. What do we know? We are given that the set of vectors u and v spans V. We want to show that the set of vectors u and u plus v also spans V. Now, before we go to the next page, the first thing that comes to my mind is, what does it mean to span a vector space? That means every vector in this vector space V can be written as a linear combination of u and v. Every single one of the vectors, right? So when I get here, I'm going to pick an arbitrary vector in V, and I called it W. To show that the set of vectors u and u plus v spans V, I need to find scalars c1 and c2 such that W is equal to c1u plus c2 times u plus v, right? That's what it means to span a vector space. Every vector in V can be written in terms of u and u plus v. So this is my goal right here. But what do we know? We know that the set of vectors u and v also spans V. So we can find scalars k1 and k2 such that W is equal to k1u plus k2v. Now, the object here is I want to express scalars c1 and c2 in terms of the known scalars k1 and k2. If I can do that, that means I can write W as a linear combination of u and u plus v. Because right now, we don't know what these scalars are. We have no idea. But we do know what these scalars are because it's given that the vectors u and v in that set span the vector space. Okay, so again, I want to write unknown scalars in terms of these known scalars. That's the goal. Now, look, I'll give you a secret here. If I take W, right, the vector W, that's equal to c1u plus c2 times u plus v. But that's equal to c1u plus c2u plus c2v. But this is equal to c1 plus c2 times u plus c2v. Okay? Now, what that suggests is that I want to take c1 plus c2 and set it equal to k1, right? Because if we look over here, remember W is equal to k1u plus k2v. And it also suggests that I want to take c2 and set it equal to k2. But if I replace c2 with k2, we get c1 is k1 minus k2, right? Because notice I take c1 plus k2, that's equal to k1. So c1 is k1 minus k2. And so W is equal to k1 minus k2 times u plus k2 times u plus v. And so notice W is a linear combination of vectors u and u plus v. And so that set turns out to span the vector space V. And that's how you do problem number 23. And that'll conclude this video for section 4.3, and we looked at problem 23. Thank you.